So to round out our collection of formulas we can use to find derivatives of all of the functions we know, we just need formulas to find derivatives of logarithmic functions. Well, it turns out now that we know how to take the derivative of an exponential function, we could use that pattern, that formula, that process, to find the derivative of their inverses. The inverses of the exponential functions are the logarithmic functions. So imagine a function y equals natural log of x. I could exponentiate both sides, which means make both sides the exponent on e. So y turns into e to the y, and natural log of x turns in e to the natural log of x. But e-ing and natural logging cancel each other out, which just leaves me x. So now I can take the derivative of both sides with respect to x. This is implicit differentiation because I don't have y all by himself. When I take the derivative of e to the y, that's e to the y dy dx. The derivative of x, of course, is 1. So when I isolate dy dx, I get 1 over e to the y. Well, we don't want to leave y's in a derivative formula that started with x's. Remember, my original problem was y is natural log of x. So my next step, notice that e to the y is equal to x, and I can just make that replacement. So the derivative with respect to x of natural log of x is 1 over x. If we want to incorporate the chain rule in our little derivative rule, the derivative with respect to x of natural log of u is 1 over u times du dx. Here's an example from your paper. I want to find the slope of the tangent line to natural log of x squared at the place where x equals e squared. So this is a two-step process. I need to find y prime first, and then I'm going to plug in e squared for x. So I'm going to take the derivative of natural log of x squared with respect to x. My u in this case, the thing getting natural logged, is x squared. So my derivative, 1 over u times du dx, is 1 over x squared. Derivative of x squared with respect to x is 2x. So I get 1 over x squared times 2x, which of course simplifies to 2 over x. Now when I want to find out dy dx at the place where x equals e squared, remember this notation we can use. So dy dx evaluated at, that tall line, evaluated at x equals e squared is just 2 over e squared. So the only thing left that we have to learn how to take the derivative of are logarithms with different bases. Remember, the natural logarithm is a logarithm with base e. Now to take the derivative of logarithms with any other arbitrary base. Log base 10 is probably the one you see the most, but any other base you want to use, it's a similar rule. The derivative with respect to x of log base a of x is 1 over x, and that x is getting multiplied in the denominator by the natural log of a. Or if I want to use the chain rule version, the derivative of log base a of u is 1 over u natural log of a times du dx. So make sure those are in your paper. We're going to do one more example. Okay, so here we go. When I take the derivative with respect to x of log base 5 of square root of x, before I move the slide, can you figure out what a is? Can you figure out what u is? And if you figured out what u is, can you figure out du dx? Okay, good. So a in this case is 5. U is the thing getting logarithmed, which is the square root of x. Derivative of square root of x with respect to x is 1 over 2 root x, or 1/2 x to the negative 1/2. So I'm going to use my formula, the derivative of log base 5 of square root of x. That's the derivative of log base a of u. It's going to be 1 over u times, still in the denominator, the natural log of a, natural log of 5. And then I'm going to multiply by du dx. So you can see I have it here. So 1 over square root of x times the natural log of 5. I'm going to multiply by the derivative of square root of x, which is 1/2 x to the negative 1/2, or 1 over 2 square root of x. Notice the radical x and the radical x multiply together to make regular x, and I end up with 1 over 2x natural log of 5. Of course, if you're on the free response section, you have no obligation to simplify that answer. And then here we go. That's it. So make sure you have all 4 of these formulas written into your notes paper. Once you've learned how to take the derivatives of logarithmic and exponential functions, your ability to complete more problems on your free response notebook sort of skyrockets. So take another look through the free response notebook, see what you can do now.